Good morning everyone. Today we are going to do salt analysis. We know that salt is a product of acid and base. The radicals comes from acid is called acid radical, and the radicals comes from base is called basic radicals. Acid radical is always negatively charged and also called anion. Basic radical is always positively charged and also called cation. So a salt consists of, generally a salt consists of two radicals. One is acid radical and other is basic radical. In salt analysis we need to identify the radicals only. Here I am giving you some examples of inorganic salts. For example, ammonium chloride, NH4, Cl, lead nitrate, PbNO3, whole 2, copper sulfate, CuSO4, aluminium chloride, barium carbonate are some examples of inorganic salts. Here ammonium is positively charged, chloride is negatively charged, lead is positively charged, nitrate is negatively charged, copper is positively charged, sulfate is negatively charged, aluminium is positively charged, chloride is negatively charged, barium is positively charged, carbonate is negatively charged ions. Here all the positively charged ions are called cations or basic radicals. And the negatively charged ions, chloride, nitrate, sulfate, chloride, carbonate, these are the examples of anions or acid radicals. In salt analysis we have to find out the radicals present in an unknown salt. So now we are going to start our practical. This is an unknown salt and we don't know what is the name of the salt. We need to find out the radicals present in it. So in physical observations, the first point is color. So what is the color of the salt? It is white. White means colorless. So here you can write colorless. Here you can write colorless. Then physical state. What is the physical state of this salt? If your salt have definite geometrical shape, salt sugar like structures, then it will be crystalline. If your salt looks like talcum powder, have no definite geometrical shape, then it is amorphous. So give a close look here. It is sandy and it is looks like salt sugar. It has definite shape, so it is crystalline. Here you write crystalline. Physical state is crystalline. Come to the next point, solubility. For solubility test, take a pinch of salt in a dry test tube, then you put here water, 2 ml sufficient. This is approximately 2 ml. Then you try to dissolve it. This is the right process of dissolving a salt. Now you see the solution becomes transparent. It is very clear and very transparent. So it is soluble in water. Here you write solubility, soluble in water. Okay, physical observation is completed. Now we are going to do dry test for acid radical. First we will detect the acid radical, then we go for basic radical. So in dry test there are two tests. Number one test is dilute sulfuric acid test, and number two test is concentrated sulfuric acid test. Remember, all dry tests are called preliminary test and all wet tests are called confirmatory test. For dilute sulfuric acid test, you take some dry salt in a dry test tube, then you add dilute sulfuric acid. This is the dilute sulfuric acid. After adding dilute sulfuric acid, if you get effervescence, if you observe effervescence, that it indicates carbonate radical. If you get rotenic smell, then it indicates sulfide radical. If you get suffocating gas, then it indicates sulfide radical. If you get brown fumes after adding dilute sulfuric acid, then it indicates nitrite radical. So here you observe very carefully. This much sufficient. Always use less amount of reagent. No effervescence, no brown fumes, no pungent smell of rotten egg, no suffocating gas, means all the four radicals are absent. Carbonate, sulfide, and nitrite are absent. Therefore, here we can write in dilute sulfuric acid test, in observation no observation, and in inference carbonate, sulfide, and nitrite are absent. Again, concentrated sulfuric acid test gives observation of four radicals: chloride, bromide, iodide, and nitrate. If chloride is present, then you will get pungent fumes of HCl. If iodide is present, you will get violet fumes. If bromide is present, you will get brown fumes. If nitrate is present, then after strong heating you will get brown fumes. Now we are going to perform the concentrated sulfuric acid. Take dry salt in a dry test tube. Then you put here, this is concentrated sulfuric acid. Then you put here concentrated sulfuric acid, very less amount. Use less amount of reagent. Here you see very light white fumes is coming, and it is very pungent. It smells very pungent. So it is the observation for chloride. If you get this type of observation, then you do one thing: you take a glass rod and dip the glass rod in ammonium hydroxide solution and place the glass rod on the mouth of the test tube. Then you will get dense white fumes. This is the dense white fumes. You see, this is the dense white fumes of ammonium chloride. Okay, so we got observation for chloride radical. Dry test for acid radical is completed. In concentrated sulfuric acid test, we got some observation. So here we can write in observation: pungent fumes of HCl gives dense white fumes with ammonia solution. Okay. In inference, you write chloride may be present. This is preliminary test. So here we are writing may be present, not confirmed. Now we are going to do wet test for acid radical. There are two parts. One is barium chloride test, another is silver nitrate test. Barium chloride test gives confirmation for two radical. One is carbonate and other is sulfate. Again, silver nitrate test gives confirmation for three radicals: chloride, bromide, and iodide. For silver nitrate test, we need to prepare salt solution. Take some salt in a test tube. Then you put water and dissolve it. So this is called salt solution. Then we have to add here silver nitrate solution. This is silver nitrate. After adding silver nitrate solution, if you get white precipitate, then it is chloride. If you get pale yellow precipitate, then it is bromide. If you get fully yellow precipitate, then it is iodide. So we got white precipitate. So this is the precipitate of silver chloride. Okay, this precipitate will be dissolved in ammonium hydroxide. This is the ammonium hydroxide. You put here ammonium hydroxide. Now you see the precipitate is dissolved. This is transparent. This precipitate is dissolved. So chloride is confirmed. We can write here in silver nitrate test, we got white precipitate and the precipitate is dissolved in ammonium hydroxide. White PPT soluble in ammonium hydroxide, chloride confirmed. So acid radical is detected and it is chloride. Now we are going to perform weight test for basic radical. Basic radicals are divided into 6 groups from group 0 to group 5. Ammonium radical is present in group 1, lead is present in group 2, copper is present in group 3, aluminium iron is present in group 4, nickel, cobalt, manganese, zinc is present in group 5, barium, calcium, strontium is present in group 6, magnesium is present. So for group 0, the group reagent is sodium hydroxide and Nessler's reagent. First we have to prepare salt solution, then we add here sodium hydroxide solution. This is sodium hydroxide, and after that we have to add here Nessler's reagent. After adding Nessler's reagent, if you get brown fumes, then it is confirmed that 0 group is present. If you get other colored precipitate, then it is not 0 group. If you get white precipitate or yellow precipitate, then it is not a 0 group. You add here 2 or 3 drops of Nessler's reagent. Here we got brown precipitate. So here this 0 group is present. In 0 group ammonium is present, so our basic radical is ammonium and it is confirmed. So here we can write brown PPT, and in inference you write group 0 is present. Within bracket you can write ammonium. In group 0 ammonium ion is present. You write the result. By the systematic analysis we got the acid radical chloride and the basic radical is ammonium. Hence the given unknown salt is ammonium chloride.